Let's talk about the mole concept. If you had chemistry in high school, you have heard of a mole. What do y'all know about a mole?
6.22 times 10
Close. 6.02. Yes. A mole is 6.02 times 10 to the 23rd. Well, what does that mean?
atoms in the molecule.
Yes. If I say dozen, what do y'all think of when I say dozen?
12.
You think 12, right? And we're familiar with things coming in dozen. Eggs, donuts, maybe other things as well, okay? But that's the most common. So whenever I say 2 dozen, you know I mean 24. Can you have half a dozen? Well, sure, you can have 6, okay? When it comes to dozen, it's kind of hard to have, 0.471 dozen, okay? But that's not the case with the mole. A mole is like a dozen, but a mole is always 6.02 times 10 to the 23rd stuff. What? It can be atoms, it can be molecules, it can be ions, it can be any of that, okay? And so that's what a mole is.
So a measurement of.
Counting measurements, what it is. Now, if I have a mole, and the abbreviation for mole, y'all, is MOL, it just drops the E, okay? Let's say I had a mole of helium. Well, a mole of helium, how many helium atoms would that be? That would be 6.02 times 10 to the 23rd helium atoms. That's quite a few helium atoms, right? Because 6.02 times 10 to the 23rd means take that decimal and move it 23 places to the right. That's a big number, a mole is. How much would that weigh? What would the mass of a mole of helium be? It would be 4.00260 grams of helium. Where did that 4.00260, where did that number come from? Came from the periodic table. The mass number, the red number under each element, do y'all remember last time we had class, we used those to measure the mass of a single atom, right? And do you remember then that the units were AMUs, or atomic mass unit, because it was the mass of a single atom. That same mass in grams, which you see here, 4.0026 grams, is the mass of a mole of atoms. Okay? So, what if, that's a mole of a single atom, a mole of helium. What if I were talking about a mole of water? How many water molecules would that be? A mole of water. Not a trick question. What did we say up here? A mole is... Exactly. So a mole of water is 6.02 times 10 to the 23rd water molecules. How many grams of water would that be? Okay.
18.02.
Yes, 18.02 grams of water. Where'd you get that?
Added the 2 hydrogens and oxygen.
Just like I did atomic masses last week, y'all said there's 2 hydrogens, and each hydrogen is 1.01 grams, and there's 1 oxygen, and each oxygen is 16 grams, and we add that up, and we get 18.02 grams of water. Remember doing that last week, and then we worked with those numbers and did percent composition as well? Okay. Table sugar is sucrose. just for your information. Does anybody know what the formula for sucrose is? I wouldn't expect you to know it for our class, but just because you've been in biology or A&P or something. No, it's a bunch of carbons and hydrogens and oxygens. Sucrose is C12H22O11. That's table sugar. Okay? So what if I had 1 mole of sucrose? A mole would be 6.02 times 10 to the 23rd sucrose molecules, right? How many grams would that be? Y'all are going to need a calculator for that one. Okay, what'd you get for grams of sucrose?
I got 342.34.
342.34 grams. Does anybody else agree with that? That's what I got, 342.34. Where do you get that number from, y'all?
Say 12 times 12.01.
Right. There's 12 carbons in sucrose. Multiply that by 12.01 grams.
That's 144.12.
Okay.
Say 22 times 1.01.
And then 22 times 1.01.
And then 11 times 16.
And then 11 times 16.
Yeah.
Multiply all that together. Add them up. And I got 342.34 grams. Is everybody getting that? And everybody see where that number's coming from? So I've written, if I go back to the sucrose one, the sugar, that a mole of sucrose is that many sucrose molecules is 342.34 grams of sucrose. Guys, do y'all see that this is the same way of saying like a yard is equal to 36 inches is equal to 3 feet? Okay, so is this equal to this? Well, yeah, because a yard is also equal to 3 feet, right? So a mole is also equal to this number. All of these numbers are equal no matter how we relate them. So, if I know that a mole of water, let's go back to that one, is 6.02 times 10 to the 23rd water molecules. Let me switch up what I'm asking you. A mole of water, how many oxygen atoms are in a mole of water? Okay, let's think about it. If there are 10 cars in the parking lot, how many tires are in the parking lot? There are 10 cars, how many tires? 40. Agree? How do you know that? There's 4 tires for every car, right? So if there's 6.02 times 10 to the 23rd water molecules, each water molecule has how many oxygens? Each molecule has 1 oxygen. So how many oxygen atoms would that be? Yes, it's still 6.02 times 10 to the 23rd oxygen atoms. Does that make sense to you? Yeah? No? Okay. If there's 10 cars, then there's 10 engines, right? Because every car has 1 engine. So if there's this many waters, then there's that many oxygen atoms, because each water has 1 oxygen. Okay? How many hydrogens does each water have? Each water has 2 hydrogens. So, what if the question said a mole of water equals how many hydrogen atoms?
12.04.
Yes, that answer would be 12.04 times 10 to the 23rd. Because there's 2 hydrogens for each water. And there's 6.02 times 10 to the 23rd waters, so there's 12.04 times 10 to the 23rd hydrogen atoms. Made me think bicycles. because you got frames and wheels, right? There's one frame on each bike, so if there's 50 bikes, there's 50 frames. But if there's 50 bikes, there's 100 wheels. Make good sense? Okay. With this mole concept, y'all, is we have a conversion between moles. Let me start over. Grams and moles and number of stuff. And that stuff can be atoms, molecules, ions. To relate moles to the number of stuff, we use that number. What number do we use to go from moles to the number of stuff? 6.02 times 10 to the 23rd. What concept gets us between grams and moles? What number? Well, it's called, I'm going to put MM here. MM stands for molar mass. What is a molar mass? It's the mass of 1 mole of something. And y'all have already been doing molar masses because you came up with 18.02 for water, grams for a mole of water. You calculated 342.34 grams for the table sugar. You calculated 100.09 for the calcium carbonate. I showed you the copper wire, and you said, well, that's going to be 63.55 grams. So it's just the mass of a mole of something. So remember this flow chart, because this is how you're going to convert between what you're starting with and what I'm asking for. For example, a penny. How much do y'all think a penny would weigh? Of 3.21 grams. Calculate the moles of copper in that penny, and we're going to assume our penny is solid copper. And then B, I want you to also calculate the number of copper atoms. If we look back at our flow chart that we just wrote, to go from grams to moles, I use a molar mass. Molar mass of what for this problem? Molar mass of copper. What is the molar mass of copper? 63.55. So to set part A up, you're going to start with what you're given in the problem. The problem says that you've got 3.21 grams of copper, because we're assuming our penny is solid copper. The first thing we're looking for in A is how many moles of copper that is. So do you guys see that I'm going to put moles of copper on the top of this conversion? And what's going to go on the bottom? Grams of copper. Now this is a conversion, so how do I make moles of copper and grams of copper equal to each other? Well, a mole of copper, isn't that going to be 63.55 grams of copper? Right? We just get the number from the periodic table. And again, this, I showed you earlier, this coil of copper wire, that's 63.55 grams. That is 1 mole. They're the same amount, they're just different units to measure that. Punch it in our calculator, and I got 0.0505 moles of copper. Is that what y'all got?
We did work with that conversion.
Well, I what now? Now, how are we going to work the second part of that problem? The number of copper atoms. I'm going to go back and refer to our flow chart. You can go straight from grams to atoms, or you can go from moles to atoms. But do you see that to calculate the number of atoms, we're going to need this number, 6.02 times 10 to the 23rd. What do y'all want to start with as far as this problem goes to work part B? What number do you want to start with? You want to start with moles? Okay. So we're going to start with 0.0505 moles of copper.
How would you start with grams, like just in case you got A wrong?
Okay, good point. I'll do that one right after I do this one, okay? All right, if I'm going to start with moles of copper, then what units do I want to cancel?
Moles.
I want moles of copper to cancel, so I know that needs to go on the bottom. What am I looking for in B? B asks for copper atoms. So I'm going to put copper atoms on the top.
So whenever you want something to cancel, you put it on the bottom.
Right. How can I relate moles of copper to copper atoms? How are those equal to each other? Well, isn't a mole of anything 6.02 times 10 to the 23rd of those? Okay? So do you see that 6.02 times 10 to the 23rd is going to go on top? Huh? A large number. A big number is what I'm looking for. 0.0505 times 6.02 times 10 to the 23rd. I got 3.04 times 10 to the 22 copper atoms. Is that what y'all got? That's a big number. We would expect there to be a lot of atoms in a penny. Any questions? So you ask, what if instead of on B, what if I didn't start with 0.0505? Because that, I'm assuming that I got A right. So a lot of us would go back to the 3.21 grams and start with 3.21 grams and say how many copper atoms is that? Well, what units am I trying to get to cancel? Grams. So that's got to go on the bottom. Agree? What units am I wanting my answer in? Atoms. And specifically copper atoms. How can you relate copper atoms to grams of copper? Do you know a number that relates those two? You know that 63.55 grams of copper is 6.02 times 10 to the 23rd copper atoms. Right? And when you work this out, it's different than what we did in B, but you're going to get the same answer because that is the right answer. You're still going to get 3.04 times 10 to the 22 copper atoms. It's just a different way to work it. It does not matter which way you work it as long as you get the right answer because there's only one right answer. Let's say that a certain experiment calls for 0.785 moles of potassium nitrate. How many grams of potassium nitrate will be needed? What's that formula? Potassium nitrate.
KNO3.
Very good. KNO3. Right, since the 0.785 moles is what I'm given in my problem, I know I've got to start with that many moles of potassium nitrate. What units do I need to cancel out? Moles. So therefore, that's got to go on the bottom. What is the question asking for? Grams. So I'm going to put grams on the top. Now, what numbers am I going to use to make this grams of KNO3 equal to moles of KNO3? I'm going to use that molar mass. So I know that a mole of potassium nitrate equals, I go to the periodic table and I take the 39.1 for the potassium, the 14.01 for the nitrogen, and the 16 for the oxygen, and there's 3 of them. And for the molar mass, I got 101.11 grams. Is that what you guys came up with? Okay. And that's it set up, because see, moles of potassium nitrate is going to cancel. So I punch that in my calculator, and I got 79.4 grams of potassium nitrate for my answer.